if you've tried processing large volumes of data in n8n or just large number of items, you've probably run into an error like this, where n8n stopped the execution of a particular node and basically crashed because it ran out of memory. Or maybe it was something like this, where you can't run one isolated node because the data in memory is already too large. In this video, I will show you a couple of really powerful tricks to work around these problems to be able to process much larger volumes of data. Hey, my name is Ivan. I've been leading teams and shipping software for over 15 years, and lately I've been helping companies introduce AI into their processes in order to get more clients, reduce their costs, or simply serve their current clients better. So let's get into the video. So for this example, I've taken out a part of a workflow from a much larger workflow to sort of isolate the part of it that produces the problem. So what I've got is an Epify scraper, or in this case, I'm just getting the dataset items from that scraper. So I've got a run here. So this is a LinkedIn job scraper, and I was fetching 2,000 items. So that's a fair bit of data. It says storage size 3.2 megabytes, but this is, I think, compressed. And also, some scrapers for the same number of results might actually end up with 30 or 50 or 100 megabytes of data. Now, n8n being run on top of Node is not super memory efficient, and the memory you see here is actually just a fraction of the amount of memory this is actually going to use once all of these items are loaded into memory into your workflow. Now, a typical way you build a workflow like this is you would just have that node, you would download the items and then process them one by one in some kind of pipeline. And this is a self-hosted instance of n8n. So it has a lot more memory available than what you would have on a cloud hosted instance. And so for me, I was able to actually download these 2,000 items, but I would still have a lot of trouble actually processing them. And so going, if the workflow was complicated enough and I had a number of nodes that are doing something with these 2,000 items, I would still probably run out of memory. On a cloud instance, the amount of memory you have available is much lower, and this wouldn't even run. So if you try to do something like this, it would probably just crash and give you that error I showed you at the beginning. So when that happens, n8n is going to give you a link to this document that explains how memory works, why these types of errors happen, and how to avoid them. So the typical causes, there's a bunch of reasons here, and the most typical one I've found is the amount of JSON data. So this is exactly the situation we had, or the size of binary data. That would be if you're downloading some files and so on. Now, it also says some nodes are memory heavy, like the code node. Then you've got manual workflow execution that is problematic, and then additional workflows running at the same time, which is also a problem because if you have multiple workflows running in parallel, they're all eating into the same memory. Now, in terms of possible solutions, well, some are easier and some are harder. So the first one they have is increasing available memory, and on n8n cloud instance, that means upgrading your plan. Now, the thing is, if you look at the plans, this is memory limits on each cloud plan. They give you 320 megabytes per instance on a starter plan. Like, this is really, really low, especially for the amount of memory something like a node process needs and something like an n8n application. Then if you upgrade to Pro 1, which is 10,000 executions, you get 640 megabytes of RAM, which is still pretty low. And it's only once you get to Enterprise where you get 4 gigabytes of RAM that you might actually be able to just get away with, around these issues and processing a lot of data without running into memory issues. But then the question is, okay, if we can't really do that, what are the options? Well, it actually gives some good ideas here. And when I was first reading this, I kind of misunderstood what it was suggesting. And so I went through a couple of iterations before I found the approach that actually solves the problem. So here is what I've tried, what didn't work, what did work, and why. So after I tried, with the naive approach and just downloading all the items, I realized that's not going to work. So my next approach was trying to split things into batches and going through a loop and just getting a smaller number of items in these batches to try to avoid getting all 2,000 items at once. That was my initial understanding of the documentation that n8n has. And when I tried this on an n8n cloud instance, it didn't really work. So I'll show you what happens if I run this. So if we execute the workflow, it will go through and run the loop and basically get 50 items by 50 items. So the way that works is this runs in a very similar way to how you would have a loop in any programming language, where it initializes some kind of counter. So we've got a number of items is 2000. Again, this would all be coming from outside from the results of running an actual actor, which would give you the number of items and all of that. This is just a shortened example to isolate the problem. So we've got 2000 items. We start with the offset of 0, which means we start from the first item, and then our page size is how many items do we fetch at once. So in this case, I'm using 50. And so from there, we have the update loop, where we basically just take the offset from before. That will become clear in a moment. And then we get the data set items, but we get the items starting from the offset. So the offset will be 0, then will be 50, then will be 100, and so on. And we take the limit, which will be the page size. After that, I've just inserted a dummy node, which does something with the items. So maybe you'll be storing them in a database. Maybe you're going to be processing them in some other way. And then we increment the offset. Now, this is the key, where we basically take that offset we just had before in that node, and then we add the page size to it. So if the offset was 0, we add the page size, it becomes 50, and we store that in the output variable called offset. Now, what happens is that runs through here, and in update loop, we read that variable. So it was 0 before, now it becomes 50. So we start from the 50th item. As it runs through, it's going to be increased by 50. So we're going to start from 100. And so that's how it goes through the whole loop and basically fetches all the items from the first to the last. The last part here is the test that checks whether we've reached the end of the loop. So we basically check whether the offset is still less than the whole number of items. If it is, then we run again. If it's not, then if the offset is less than the number of items, then we're gonna go again and run another iteration of the loop. And if we've reached the whole number of items, then we're just gonna exit out. And in this case, I'm not really doing anything with it, but potentially you might be doing something with the data. Now, here's the problem. If you look at here, you'll see that there's still 2000 items here and 2000 items here. So what's happening is we have this node that's been run 40 times, and each of the 40 times it was processing 50 items. But because this is one execution of the workflow, all of this data is kept in memory. So all 2000 items are kept in memory here. All 2000 items are kept in memory here. And if you had a whole bunch of other nodes following it, all of that data would be stored in that one single workflow execution, and that's why it still runs out of memory. So for all intents and purposes, memory-wise, it's no different than just doing it this way. So that was my first approach, didn't work. Now, the approach that did work, and what's actually suggested in the documentation, which makes a lot more sense, is to split this out into a sub-workflow. And that's really something I found to be a solution to this problem, but also a few other problems I'll mention along the way. So this is how it works. We still have the update loop, but instead of fetching the data and processing the data inside of this workflow, we shift this over to another sub-workflow. And the reason this works is because when we go into the sub-workflow, which looks like this, which is essentially those few nodes I had before, we get the dataset items, which is 50 items. But then when we finish with this execution of the sub-workflow and we get back, those items are forgotten. We don't need them anymore because they're not part of this execution. And that way, you're never remembering or all 2000 items or however many you're processing. You're just remembering one batch of items, and that would be in your sub-workflow. So if I run this version of the workflow, you'll notice something different, which is that as we're running through this, you're not seeing 50, 100, 150. You're just seeing like 1, 2, 15, whatever. And so if you divide our 2000 items by 50, what that's going to end up is 40. So all we're remembering here is just 40 items. So we're at 29 now, 31. So in a few more seconds, we're going to get to 40, and that's where everything stops. So we're not remembering 2000 items at once, and that's really the key. Now, for this to work, there's something else important you have to watch out for in your sub workflow. Now, in this sub workflow, if I was doing this and sort of just deleted this part of the workflow, I would still be having the same problem because this sub workflow returns the results of the last node it runs. So if I was getting my 50 items, then in my workflow here, this would be returning 50 items. Then the next run it would be next 50 items. And so in 40 runs, I would still have all 2,000 items that I'm remembering. So in order to avoid that, what you need to do is kind of collapse that. So I'm aggregating these 50 items into one. And then to make things even better, instead of returning all the data, because aggregate, depending on what these nodes are returning, might just still contain all of the data, I'm just having this set field, which basically just sets one variable to one value, and that's it. So that's a very, very small amount of memory that I'm actually returning out of the workflow, because that gets remembered in that main workflow. Now, there might be situations where what happens if you actually need those items? Well, if you needed those items and you needed to somehow process them further in that big workflow, the only other way to do that would be to store them in some kind of database. And then in the other workflow, just sort of like go through them again one by one instead of having to keep everything in memory. And so that solves that problem. It solves the problem where it tells you that run you can't run just one node in a workflow because the data is too large, and so on. So that's a way to process large amounts of data in n8n. Now, n8n is not built for this. That's the reason why you have to build these workarounds in order to make this work at all, because it's simply not meant as something that's supposed to, process gigabytes of data and have big and huge pipelines. So when you get to the point where you are dealing with so much data, well, even at this stage where I've got 2,000 items, I should start questioning whether n8n is the best choice for this, or whether I should be just doing that in code in some kind of backend service and so on. But if you do find yourself in a situation where it's kind of like on the, borderline, and you don't want to rewrite everything in a full code backend API, then this might help and let you, push through and get n8n to process that data for you. So I hope that helps. And if you'd like me to help you optimize processes in your business to help you get more clients, save money, or serve your current customers better, feel free to book a call in the link down in the description, and let's have a chat.